Hello, my name is Grandor, and for my screencast problem, I have selected a problem from week 10, set 9, and we're going to be taking a look at problem number 4. The problem states, let V sub n denote the number of divisors of n, and we are going to classify all these n's for which V sub n equals 2, V sub n equals 6, and V sub n equals 7. Before we dive into this problem, there's a principle that we need to go over, which will help us identify the number of divisors of n. And this will come in to a lot of help when we start dealing with numbers that are much greater than n. Again, before we solve this problem, I'd like to review one principle when it comes to finding the number of divisors for a certain number n. So we start at the top. Suppose our number n is represented as the following. N is equal to piece of 1 raised to the a power times piece of 2 raised to the b power, and then times to our last prime, prime of n raised to the c power. So notice what we're doing with our number n is we are doing the prime factorization. We get all of our primes and then we identify the number of primes that we have. Once we have completed the prime factorization of n, we can now move on to our most crucial part. With this in mind, the total number of divisors can be found by taking our exponents a, b, c, and so on, and writing them in the following format. If we take a plus 1 times b plus 1, and then lastly our last exponent c plus 1, that is going to equal the number of divisors that we have. I do want to take the time to go over one example so you can see this process in full action. For example, let's say our number is 720. We want to find the number of divisors of 720. Now, if we wanted to, we could manually go through and start identifying, okay, which whole numbers are going to be divisors of 720. But let's go ahead and use this idea that we just covered. We are going to start with the prime factorization of 720. If we take a look at it, and you can check this on your own if you want to, 720 is going to be equal to 2 to the 4th power times 3 squared times 5. And let's just go ahead and say that's to the 1st power. And again, it's the simple prime factorization. I get all my primes, and then I identify that I have 4 2's, 2 3's, and then 1 5. Now herein lies the key to this whole process. It's the idea that we are not just concerned about the primes, but more importantly, we're concerned about the number of times these primes occur. Let's take, for example, that 2 to the 4th power. The number 2 appears 4 times. So when we go to create our total number of divisors of 720, we start with our first prime, and we establish that it occurs 4 times, so that's going to be our A, and we're going to take that plus 1. Let's move on to our second prime, which is 3. Notice 3 occurs 2 times. Therefore, we're going to take 2 plus 1. And then for our last factor, 5, notice that prime occurs 1 time. Therefore, we are going to go 1 plus 1. So if we go back to our previous statement, we identified that our A, B, and C, our exponents, are going to be 4, 2, and 1, and we simply plug those in respectively. Now if we go ahead and finish and simplify, 5 times 3 times 2, you can see that that's going to get us 30. And you can go ahead and again manually find the number of divisors of 720, but as you can see, this process is much simpler and saves us a lot of time. Therefore, the number of divisors of 720 is indeed 30. So with that process in mind, let's go ahead and move on to part A. We want to classify all n for which V sub n equals 2, which is simply stating we want to classify all n's for which that n has 2 divisors. Now if you think about it, what makes it only have 2 divisors? Well, simply put, it's just by taking a prime times 1. For example, if we look at the number 7, the only divisors of 7 are simply going to be 1 and 7 because they're prime. There are no other factors that can divide 7. If we take a look at another one, 13, as you can guess, the only factors, or the only divisors of 13 are again going to be simply 1 and 13. So for the first part, how can we classify all n for which v sub n equals 2? We can do that by simply stating that n must be prime. As long as n is prime, we will always create two divisors. For part B, now we want to classify all n for which v sub n equals 6. We go back to our original idea. It's the fact that a plus 1 times b plus 1 times c plus 1 and any other exponents that we may have is going to be equal to 6. And recall a, b, and c are the exponents, and they represent the number of times that a particular prime occurs in that prime factorization. So for this particular problem, we basically have two cases. Number one, if I take a look at our structure, we need to come up with some a and b values that when we add 1 to each a and b, we still get 6. So if I start, notice that if I use a 2 here, along with a 1 here, when we simplify, we get 3 times 2, and notice that works out perfectly fine. So, for our first case, what we need is the fact that a needs to be 2 and b needs to be 1. So how can we classify this for all of our n's? So, n can be equal to, let's say, p sub 1, where that's our prime number, is raised to the second power times p sub 2, simply to the first. And notice again our exponents are 2 and 1, so when we plug it into our idea, 2 plus 1 will get us 3, 1 plus 1 will get us 2, and the product of those two values will get us a product of 6. This is going to represent the first case for classifying all n's for which v sub n equals 6. The last scenario where we can get this product to equal 6 is simply when we decide that our a value can be 5 and our b value is 0. If we go ahead and simplify, 5 plus 1 is 6, 0 plus 1 is 1, and 6 times 1 will definitely get us 6. So how do we want to represent this n? Simply enough, we can state that n now is going to be equal to some prime, a, raised to the 5th power, times p sub 2, raised to the 0 power, which if that prime does not show up at all, is simply some prime to the 5th power. As long as we have some prime to the 5th power, we can say that can represent our n, where we are only going to have 6 divisors, and exactly 6. That is our second way that we can represent n. So in conclusion, for classifying all n for which v sub n equals 6, the first case is when n is equal to some prime to the 2nd power times a different prime to the 1st, and then also when n is equal to some prime to the 5th power. And this all relates back to our idea of adding 1. Our last part is part C, where we classify all n for which v sub n equals 7. Now if we take a look at the number 7, I think it's fairly obvious that 7 is a prime number, which means the only factors of 7 are 1 and 7. So when we come up with these two factors, those are the only ones that work. So with this in mind, this leads us to our only case that we could come up with. Again, if we simply want to have 1 and 7 to equal 7, that means our a value must either be 0, and then our b value must be 6, and that'll satisfy that the product of those two is going to be 7. So with this in mind, we can go ahead and classify all n for which v sub n is equal to 7. We can simply state the following. N has to be equal to some prime raised to the 6th power. If we wanted to, we could go ahead and identify a different prime raised to the 0 power, but I think we all know that prime raised to the 6th power. That is the only way where we can use our idea and come up with a product of 7. Therefore, how can we classify all n? N simply must represent some prime raised to the 6th power. As long as we have one unique prime raised to the 6th power, we will always guarantee that we will only have 7 divisors. In conclusion, we have classified all n for which v sub n equals 2, v sub n equals 6, and v sub n equals 7, where v sub n denotes the number of divisors of that specific n. I hope you enjoyed this video and was able to get a little bit out of it. Enjoy.